Welcome, and let us look at this nice question. Let us solve for x. In x squared minus x cubed is equal to 150. So the first thing is just to move this constant term to the right, or to the left rather. So we have x squared minus x cubed, now minus 150 is equal to 0. The next step is to rewrite 150 in such a way that we can obtain a number that is squared, another number that is cubed. So what we're going to do, we're going to have x squared minus x cubed. Then we can rewrite 150 as minus 25 minus 125 is equal to 0. So that we can write x squared minus x cubed minus 25 can be written as 5 squared, and 125 can be written as 5 cubed is equal to 0. The next thing is to collect the like terms in terms of the powers. So we're going to have x squared minus 5 squared minus x cubed minus 5 cubed is equal to 0. So the next thing is just to group them so that you have the first one in the bracket, that is x squared minus 5 squared in a bracket, then minus x cubed plus 5 cubed is equal to 0. So from here we're going to use identities. For the first one, we're going to use the quadratic identities, and for the second one, we're going to use cubic identities. So for the first one, we can use a squared minus b squared, and that's a perfect square, which is always equal to a plus b into a minus b. And then for the second bit, we can use the cubic identity, that is a cubed plus b cubed can be written as a plus b into a squared minus ab plus b squared. So let us implement these two identities into our expression. So we're going to have x squared minus 5 squared in terms of this will be x plus 5 into x minus 5. Then minus this x cubed plus 5 cubed in terms of this will be x plus 5 into x squared minus 5x plus 5 squared. And that is equal to 0. So if you look at these two, there is a common factor. There is x plus 5 and x plus 5. So we can factorize. We can write it outside the bracket so that we have x plus 5 into x minus 5 minus x squared minus 5x plus 5 squared, which is 25, close the bracket, is equal to 0. So we can open up the bracket, this one here, so that we have x plus 5 into, you can collect these like terms and you can start with x squared. So you're going to have x minus 5 minus x squared plus 5x minus 25 is equal to 0, so that you have x plus 5, and here now you have x squared, which is negative, and the x's, you have x plus 5x, that is plus 6x, and the constant ones, you have minus 5 minus 25, that is minus 30, is equal to 0. So at this stage, you have a product of two numbers giving you 0. So it means that x plus 5 could be 0, or minus x squared plus 6x minus 30 could be 0. So if the first one is the case, then x is equal to minus 5, which becomes our first solution of x. And if this is also true, then we can solve this as a quadratic equation and get two more values of x. So let us do that. So we can write these by dividing through by -1, so that we have x squared minus 6x plus 30 is equal to 0. So we can solve this using the quadratic formula. Remember, the quadratic formula says that the value of x is given by minus b plus or minus the root of b squared minus 4ac all over 2a. So let us substitute those values of x. So we have minus b, that would be minus into minus 6 plus or minus, then under the root you have b squared, that is minus 6 squared minus 4 into a, and a is 1, into c, and c is 30, and that is over 2 into 1. So let us again simplify this. So we're going to have minus minus is positive, so 6 plus or minus, under the root you have minus 6 squared, which is 36. So 36 minus 4 times 1 times 30, which is 120. So we have minus 120, and that is over 2 times 1, which is just 2. So it means we have 6 plus or minus under the root, that is 120 minus 36, that will be minus 84. So we have minus 84, and that is over 2. So we can rewrite minus 84 differently. We can write it as 6 plus or minus, under the root we can have negative 1 times 4 times 21, and that is over 2. So we have 6 plus or minus. So under the root we have a square, that is 4. So it means the square root of 4 is 2. Then under the root we have 21. Then root of negative 1 is I. So that is over 2. So this one can be simplified. You can factor out 2, so that you have 2 into 3 plus or minus root of 21 I, and that is over 2. So 2 here ones, 2 here ones. So it means the expression that you are left with is 3 plus or minus root 21 I. So from here we can get two more solutions of x. X can be, as we saw in the first part, x was negative 5. Then another x could be, so we can call this one x1 and this one x2. So x2 is when this is positive, that is 3 plus root of 21 I, and then x3 is when it is negative, that is 3 minus root of 21 I. Thank you for watching. Kindly subscribe.